Okay, this experiment we're going to investigate a thermistor. Now this is a thermistor. If we want to draw the circuit diagram for a thermistor, it's a kind of resistor, so we start with a resistor, but it has this funny tick through it, okay? So that's a thermistor. And what a thermistor is it's a resistor where the resistance is dependent on temperature. Now, lots of things, resistance is determined on temperature. When you did your potential difference current graphs of a filament lamp, you saw that its resistance increases with temperature. Well, a thermistor is a special sort of component, and its resistance actually decreases with temperature. Okay, so I'm just plugging it into the multimeter and just going through to get an idea of what the resistance is, and you can see that the resistance of this component at room temperature is 5.79 kiloohms. Okay, so quite a lot. We're going to have a look and see what happens when we increase the temperature. Now, to increase the temperature, what we're going to use is we're going to be using some hot water, and we're going to be using a beaker. Now we're going to be using one of these small beakers, and the reason is if we use one of the bigger beakers, the water takes ages and ages to cool down, and we want it to cool down fairly quickly so that we can have a look and see what happens. So we've got a beaker there. Obviously I'm using a thermometer to measure the temperature. I'm going to use my multimeter again to look at the resistance, and we're going to look at the resistance over a period of time as the temperature decreases from whatever we can get the highest temperature to be to probably about 60 degrees. So first thing is I need to be able to dip the thermistor into the water here, okay? So it's going to be quite tricky to hold it there. I don't want to be holding it, so I'm going to be using this set of crocodile clips here. And what I can do with these is I can put the thermistor in it, and then I can put that on the top of there, and it should hold the thermistor down into the water. Okay, I'm putting it that way up because I want to get the thermistor as low as possible into the water, because I want to use, well, into the beaker, because I want to use as little water as possible so it cools down fairly quickly. So I've connected up my thermistor. I'm just going to suspend that over there, okay? Then what I can do is connect up my multimeter, and again I've connected it as before, connected in the two bottom holes, and I'm going to plug it in to this point here, and also at the other end here. Okay, so that's all set up and waiting for some hot water to go in, and I've got my thermometer ready to be able to find the temperature. So I'll just make sure the hot water is as hot as possible to start with. So I'm just reboiling the kettle, and then I'm going to add just enough water so that the end of the thermistor is covered, but the water doesn't go all the way up to the top to the crocodile clips. Okay, so I'll try and get that done. Moving the multimeter out the way because I don't want to get that covered in hot water, obviously. And as you can hopefully see, I've got enough water in to cover the thermistor, but it doesn't go all the way to the top of the beaker. Now I'm waiting until the thermometer stops rising, because obviously when you put it into the beaker, it's going to take a while for the stuff in the thermometer to stop rising. I think it's just about stopped there, but I'll just wait and see. And so it's gone above 85 degrees. So all what I do now is I sit and I wait. First thing I'm waiting for is for that to go down to 85 degrees for my starting temperature. And you can see it is reducing, and I'll make sure I'm reading this at 90 degrees so that we've got 85 degrees now. So what I can do is take a reading from the multimeter. Now the multimeter is reading 0.39 kilo. So if I move that down, It's 393 ohms. So for 85 degrees, I've got 393 ohms. I'm then going to sit and wait for it to reduce to 80. And you can see why I said not to put much water into the beaker, because if we used a bigger beaker with lots more water, this would take absolutely ages. So we've used a small amount of water so that it will cool in a reasonable amount of time. You can see it's already down to 83 degrees. We'll just wait for it to go a little bit further, and I'll check I'm reading at 90 degrees to avoid any parallax error. So what's going to happen is when it gets to 85 degrees, we'll take another reading. When it gets to 75 degrees, another reading, 70, 65 and 60. You might have time to go down 55 and 50. Okay, so keep going as long as you can until your teacher tells you that, that the experiment's over. And what you're going to do when you complete the experiment is you're going to draw a graph. You're going to have temperature on your x-axis and resistance on your y-axis. Okay, so we're just about at 80 degrees. So if I read the multimeter now, 460 ohms, okay? And you can see that the multimeter, it's constantly changing, and as it cools down, you can see that the resistance is getting bigger and bigger most of the time. Okay, it just changed there just to spite me. So yeah, there we are. We've got the resistance getting bigger and bigger as it cools down. So you're going to keep going. You're going to keep looking at your thermometer. You're going to take the reading for the resistance as the water cools down. And then, as I said, you're going to plot a graph. Okay.